All right, I think we'll start now. So can everyone see the slides and can hear me okay? You can just post in the chat if you.
Yes.
All right, thank you. All right. All right, hello everyone, and my name is Angus, and today I will be teaching you how to build your very own custom PC. So I am a rising 10th grade sophomore in high school, and last year I decided to build my own PC, which you can see some pictures of me doing it. And since then, I've been using that PC to do various activities, such as playing games, video editing, my homework, and as of right now, I'm using this PC to actually show off these slides to all of you. So here is our agenda for today. We're first going to introduce what is a custom PC, and then after that, we're going to talk about each of the different parts and how to choose them. Then once we have all our parts settled, we're going to talk about general assembly instructions and installing our software. Then after that, we're going to talk about in case your computer has an issue, how to troubleshoot it and how to maintain it for the future. And after that, we're going to have a Q&A session at the very end. So that being said, we are going to begin with the introduction and talk about what is a custom PC. A custom PC is just like a regular PC you would buy from a store or a laptop. Its only difference is that instead of just buying the PC in one piece, you are buying them in individual parts and then assembling them together, like shown here. Now, what were these parts I just showed you? In total, we're going to use 8 parts to build our custom PC, which are the CPU cooler, the RAM, the disk storage, the video card, the motherboard, the power supply, and the case. Now, don't worry if you're not familiar with any of these terms or parts. In this next section, we're going to cover each of these parts one by one. So let's first talk about the CPU, which is abbreviated as the Central Processing Unit. Is that the CPU's main job for the computer is to execute instructions that is provided by the computer, which an example of an instructions that the CPU will deal with is things such as calculations, like math problems is one example. So, however, whenever we go on to a site like Amazon.com, here this is an example where it's showing 4 CPUs from Amazon. We can also see that oftentimes we also need to figure out which one we should buy. And there was a lot of vocabulary associated with each of these CPUs. For example, if we look here, we can see that it mentions processor count and it has 8 processors. So does that mean that we're going to have to install like 8 chips into our computer? Let's talk about that. So let's first go over the processor count in this example, or what's more commonly referred to as cores. So a CPU core or processor count in this example just simply refers to how many processing units the CPU has. It's important to make a distinction between the CPU chip, which as shown right here, which this would be an example of a CPU chip that's on one piece, but a CPU chip can have multiple processors units or cores as they're called. So instead of getting 8 different pieces, you would get one piece or one chip of the CPU, and that chip would have 8 cores or processing units. Now, what these processing units do is that they make the CPU easier to run tasks in parallel. A good example for this is that imagine if you were cleaning your house and you have a lot of tasks to do. You have to wash the dishes, clean the floor, and maybe tidy up your room. Now, if you only had one person to do all of that, that would take a very long time, especially when you consider that you can't tidy up your room and wash dishes at the same time. But if you had another person, then all of a sudden you suddenly can wash the dishes and tidy up your room at the same time. And that is a concept of a core in which that you are able to run multiple tasks in parallel. So, and then the second thing that we'll also see on these Amazon listings is the CPU speed. And the CPU speed is measured in gigahertz, abbreviated as GHz. And the CPU just speed refers to how many instructions the CPU can, how fast the CPU can perform instructions, in which that a higher number would be faster. So if we take the first CPU from the top and the second CPU from the top, in which that they have a CPU speed of 4.2 gigahertz and 4.4 gigahertz, assuming if both of these CPUs were the exact same except for the CPU speed, then the 4.4 gigahertz CPU would be faster than the 4.2 gigahertz CPU. One thing when evaluating the performance of CPUs, however, is that oftentimes there are changes made to the CPU that affect the performance that are not reflected in the information sheet. However, these two terms I talked about will play a big role in choosing your CPU. So next up, we're going to talk about the CPU cooler, since the CPU has a lot of circuits in them and that contain devices called resistors. And those devices produce a lot of heat to the point where the CPU can actually damage itself due to the amount of heat it produces. So we need a way to cool down the CPU, and that's the job of the CPU cooler. So one important thing to mention about the CPU cooler is that unlike a lot of other parts that we'll talk about today, the CPU cooler is actually often bundled with the CPU. For example, if we look at the bottom, this is an example where when you buy the CPU, you're actually buying the CPU cooler along with it. And whenever you're bundling the CPU cooler along with the CPU, we call this a stock cooler. But one thing to mention, of course, is that if in the example above, we can see how not all CPUs include a stock cooler. So what we need to do if this is the case is to buy another cooler from a third party, which we call an aftermarket cooler. Now regardless of the cooler comes with the CPU or not, there are three different types of coolers. The first and most traditional type of air cooler is the air cooler, which is the one we just saw in the first place, in which that the air cooler works by circulating air around the CPU to draw away heat. In which that if you get a stock cooler, it's important to note that almost all stock coolers are air coolers. But recently there have been some newer improvements in the design of the designing coolers, and one of those improvements we'll take a look at in the second type of cooler, which is the closed water loop, or the AIO. In the closed water loop, you can see how there actually is a hose leading to the CPU and then leading back to the radiator or the fans. The reason for this hose is that unlike the air cooler, the closed water loop uses water to cool down a CPU, where water is circulated in between these hoses and back to the radiator. Now, the benefits to this type of cooling is that it's oftentimes a lot quieter compared to the air cooler, and it has a greater cooling capacity. But the main issue with it is that it's a lot more expensive than just a standard air cooler. Finally, the last type of CPU cooler we'll take a look at is the open water loop. Now, in this example, these are actually entire systems with the system, but you can see here that unlike in the closed water loop where it's all in one piece, if you look closely, you can see how it's a lot of tubing that has been assembled together. sort of like how you would assemble a custom PC almost. Now, the benefits to this approach is that it provides even more cooling capacity compared to the closed water loop. And it looks quite nice. For example, in this example, these people have actually even dyed their water like red and green. But the drawbacks is that this is the most type of expensive cooling I've talked about. And also this has the highest chance of a leak happening, in which that if there was a leak to happen in this system, there would be a lot of damage to the system. Okay, Ben Dong asks the question, does the open water loop take up a lot of area? Yes, it does, in fact. Here in this example, you'll see that oftentimes you need like a big case in order to fit all of it. So that's another drawback of the open water loop. Next up, we're going to talk about the ways computers store information through two different kinds of memory. And the first one we'll talk about is RAM, or random access memory. The purpose of RAM is for the computer to provide a space where applications can store information they need to access really quickly in the future. For example, say if you are in your room and you kept a planner near you that you always needed to access and record stuff in. Now, if that planner was at your desk, that would be really convenient for you since you wouldn't have to spend much time to get it. But if that planner was all the way across your room maybe, and every time you needed to access it, then you had to walk up and go all the way to your other side of the room, it would take a lot longer compared to just having it at your desk in front of you always, which is the concept, which is why RAM is so important, to make sure that applications can have fast access to things that they really need. Now, if we go back to our Amazon listing again, in which this case I just searched up RAM on Amazon, then you will see here that the first difference you'll notice is that RAM actually comes in multiple pieces. Oftentimes, like you can see in these photos that they're actually coming with 2 pieces, or 2 sticks as they're called. And here you'll see that that also the memory, the total amount of memory is also reflected in that, as it even shows the number of sticks times the size of one stick. For example, this first one, it shows that it has 2 sticks times 8 gigabytes for each stick, which means that if you buy this, you're getting a total of 16 gigabytes of RAM. Then the next thing I'll talk about is the speed of the RAM, which is abbreviated as MHz, which stands for megahertz. This is very similar to the CPU speed of the RAM, where a higher number is faster. Only difference is that the term is different. So that's RAM, but now, if we go back to the second type of storage I was referring to earlier, is disk storage. Disk storage is, if we go back to our example with the planner in front of your desk, now let's say that you have a bunch of homework that you needed to store that you already finished, you didn't need to touch it again, but you still need to access it in order to turn it in. And the thing is that pile of homework is way too big to keep in front of your desk at all times. So the solution to this would be putting all that homework into a container away from your desk. And that's the equivalent of disk storage. Disk storage allows you to store a lot more information than at the price of it being much slower than RAM. Now, in disk storage, there are actually three major types that are actually used today, unlike in RAM. The first one is the hard disk drive, also known as the HDD to the very left, the traditional solid state drive, or the SATA SSD in the middle, and lastly, the NVMe SSD at the very end. So let's first go over the hard disk drive, in which the way the hard disk drive works is that there is a large disk in the drive that spins around, and while it spins around, there is a mechanical pin that rests on the disk and reads information through that way. The second type of disk, the traditional SATA solid state drive, is no longer relies on mechanical parts, however. Instead, it uses something called flash memory. And what this allows the solid state drive to do is that it can read information just through connecting through a circuit rather than having the disk spin around. Which the benefits to this approach means that it is a lot more reliable due to there being no moving parts, and it is a lot more faster than the hard disk drive. And then lastly, we actually have a variation of the solid state drive, and it's called the NVMe solid state drive. The NVMe solid state drive is very similar to the traditional solid state drive, except that it's a little bit faster and it is a lot smaller than the solid state drive. Here on the slide, the images aren't really fit to scale. They're not actually the size of what it looks like. But in reality, the NVMe SSD can sometimes be as wide as a quarter, while the SSDs are usually about 2.5 inches wide. The next part is the video card, or more commonly called the graphics card, or GPU. A graphics card's basic job is to output a video signal to your display or monitor. For example, without the graphics card, you wouldn't be able to see anything on your monitor or display anything. But that's only the basic job of a video card. The video card is also responsible for handling tasks like video editing, gaming, and even Bitcoin mining, because those are the tasks that the video card excels at compared to other computational parts like the CPU. The main differences in graphics cards is mainly the implementation, in which that we're going to talk about integrated graphics cards and dedicated graphics cards. Integrated graphics cards are implemented inside of the CPU or the motherboard, in which that if you buy a CPU with an integrated graphics card, you don't have to buy a graphics card separately. You can just use the CPU as a graphics card. Now, the major drawback to this is that not all CPUs include an integrated graphics card. And in terms of a dedicated graphics card, or which is one we'll cover soon, it is not as powerful. So now we can cover dedicated graphics card, in which that a dedicated graphics card has the exact same job as the integrated graphics card, except that the dedicated graphics card is now in a part of itself. It's not embedded into another part like the CPU, in which you can see an example on the left. The dedicated graphics card is also capable of providing a lot more power and computational power compared to the integrated graphics card as well. So it's also useful if you are doing an activity like I mentioned before, such as gaming, video editing, Bitcoin mining, that requires a lot of the graphics card. The next part we're going to cover is the motherboard, and the motherboard simply serves as a hub for all the parts. Every single part that we'll talk about today is connected to the motherboard in some fashion. As an example, I've listed a couple of parts such as the video card, the CPU, and the RAM, and I'll show them where they are installed on the motherboard. In reality, there are 4 more examples than this, in which that the motherboard also provides connectors and power connectors in order to provide power to all the other parts. Lastly, the motherboard is also responsible for adding some additional functionality to the computer. For example, Wi-Fi is a good example in which that if your motherboard doesn't have a built-in Wi-Fi chip, then you have to plug in a separate antenna. But if your motherboard does have built-in Wi-Fi, then you can simply just not plug in an antenna and just install the motherboard, and your Wi-Fi is already good to go. The motherboard also provides the I/O components, which is known as input and output. And input and output is basically a way of saying which of the basically more of like the ports of your computer. For example, here with I/O, you can plug in your phone into your computer if your motherboard has that, in which most motherboards do. The next part is the power supply, and the power supply's job, as it may expect, is to plug into the wall and then output all of the power to each port individually, which instead of just plugging all of it into the wall or socket at once, you're instead going to plug the power supply into the wall, and then from the power supply, then deliver the power to your components. The 2 major things you should pay attention to in the power supply is the output wattage and the power supply design. The output wattage mainly is self-explanatory, which just shows how much power it puts out in watts. You want this number to exceed the amount of power your computer uses, in which we'll talk more about that later. Then next, the power supply design is measured in whether the supply is fully modular, semi-modular, or non-modular. So here is an example of a fully modular power supply. And what this means is that all of the output cables, as you can see here, are able to be disconnected. For example, in here, there are actually no output connectors on this power supply. And semi-modular power supply is like a full modular power supply, except that there are going to be some wires that are already permanently wired to the power supply itself, so you can't remove them, but other smaller wires are able to be removed. And a non-modular power supply, as you may expect, has the design set up in a way that the wires cannot be removed. Lastly, our last part is the case, in which the case is fairly self-explanatory since it just serves as a housing for all your computer ports. Although the only major thing about the case is that the case is also responsible for your ventilation in the PC. You can see on the case, and more clearly on this left one, that the case also comes with fans. And these fans are going to be sucking air in and out of your computer to make sure your computer is getting a steady amount of airflow to keep it cool. So those were a basic summary of all the ports and what they do. If anyone has any questions, you can just share it now. But otherwise, we're going to continue to the next part where we're going to talk about how to choose each of your ports. So when choosing your ports, there are 3 things that you'll need to pay attention to. You'll first need to pay attention to your needs. You'll want to make sure that you're buying power ports that are not too underwhelming to the point where they don't get the job done, but not too overkill to the point where you're just wasting resources. The second thing you also need to pay attention to is your budget. Your budget is also very important, as you want to make sure you're getting the most out of your money. and not spending stuff on things that aren't necessary, and instead spend your money on parts that will make a difference in your performance. Lastly, we also need to pay attention to our compatibility. Is that not all parts are compatible together, and if we choose parts that aren't compatible, our PC won't work. So compatibility is extremely important, and we'll talk about that later. So some general tips when thinking about all three of these topics is that I would firstly say that research is the most important part of choosing your parts. You should first double check claims by the manufacturer and see, for example, if the air cooler you're planning to buy and the manufacturer says that, oh, it's always going to cool down your CPU, then you should double check that and make sure that if that's really the case. There are also some instances where, like the CPU I mentioned, the performance of a part cannot be gauged accurately, or it's very hard to do just from an information or specs sheet, in which then in order to find out the performance in that case, we'll need to rely on real world testing or benchmarks from previous users of that part. The second tip I'll give you when thinking about all of these is that it's very helpful to use a website to manage all your parts, which I'll give an example next slide about how it can help. And lastly, when you're researching your information about parts, the manufacturer's page is the most reliable, especially when checking compatibility. Oftentimes, there will be a lot of small things that are necessary to check if your parts are compatible or not, but they won't be displayed on sites such as Amazon.com. You'll have to go to the manufacturer's page, which will almost always display that information. So let's go to an example where using a website can help you choose your parts greatly. And this is the website I used when I built my first PC last year, and that is pcpartpicker.com. So here is a snippet of the website down below, and not only does it allows you to list your parts, I find it helpful in all the things we talked about, because first it also automatically checks for compatibility. For example, that it will actually.
他在讲我知道的东西。
It'll prevent us from choosing incompatible parts to make sure that we don't make a mistake, and it also helps us total the total price of our parts. And lastly, it also tells us the estimated wattage of our PC, which will be very important when we choose our power supply later on. And as a nice touch, they even added the place where you should actually choose your components, in which that if you choose your component, if you start from the top of the list and work your way down all to the bottom, then that's actually the preferred method of which you should choose your parts in. So I find that also to be a nice touch. But in reality, any site will work as long as it has these features. This is just one I recommend. So let's first consider your needs. And the most effective way I find to consider your needs is if you were using a previous computer beforehand. And then which that you can use your previous computer as a baseline. For example, if your previous computer was always running out of storage, but otherwise it's performing quite well for you, then you may think of buying a PC that has similar parts, just with a bigger hard drive. Or if you're on the other side, if your hard drive is doing quite fine, you have a lot of space left, but on the other side, then you see that your PC is like running slow, then you may want to like invest in like a new CPU or like maybe faster RAM. So now that we've talked about each of the parts, we still haven't talked about how they can help us in choosing our parts and how they relate to our needs. So we're going to talk about that right now, and we're starting with the CPU. My first recommendation for the CPU is that for all general consumers, I recommend that you have at least 4 cores or processing units in your CPU. And the reason for this is that that there are applications can decide how many cores they can take advantage of. For example, if you write a program that only uses one core, the other cores, if you have more than one, aren't going to be used. However, almost every single modern application, no matter how basic it is, like even Google Chrome, Microsoft Word, is all using at least 4 cores. So I would recommend that as the minimum baseline for choosing a CPU. But other than that, as I said before, choosing a CPU is something that you have to rely on real world testing, because it's something you can't just look at the information sheet and then get a good idea of how effective it is. So this is one example where you're going to have to do a lot of research about real world testing and look at other benchmarks other people have submitted. Now, the next part is the CPU cooler, and there are 2 major questions when choosing to buy a CPU cooler. The first major question is that if you get a CPU cooler bundled with your CPU, should I stick with that, or should you buy an aftermarket cooler? And my recommendation is that, again, for the average user, I recommend sticking with that stock cooler. And the reasoning for this is because that as an average user, you're not going to need the extra cooling capacity or quieter fans that the aftermarket cooler can offer. Because while aftermarket coolers do offer more cooling capacity, the stock cooler still does its job very well. And as long as you aren't running it, as long as you're not making it harder intentionally, then your CPU will be able to stay cool even with the stock cooler. But let's just say that, okay, maybe you don't have a stock cooler in your CPU, or maybe you want an aftermarket cooler anyway, which is also completely fine. So what type of aftermarket cooler should I get out of the 3 we discussed? And my recommendation for the average user, again, is the air cooler. And again, the reasoning is pretty similar, is because that water coolers and provide a lot more cooling capacity compared to the air coolers. But again, the air cooler is still going to do its job for the average consumer. And the last point I'll talk about the CPU cooler is something we haven't talked about, and that's a component called the thermal paste. Thermal paste is just a paste that is applied to the CPU in order to conduct heat from the CPU to the cooler. Now, what's important to mention about this is that a lot of times in almost all stock coolers and some aftermarket coolers, your thermal paste will already come with your cooler, or sometimes even pre-applied. But however, if that's not the case, then you need to make sure that you need to buy your own thermal paste, in which that the thermal paste you buy can really be of almost any kind, as long as you've checked to make sure it's compatible with your PC and you apply it correctly. Then the next part is the RAM, and this is where, if you have a previous PC, choosing the size of your RAM is really easy, as you can clearly tell how much RAM your previous PC is using and decide if you need any more based off your needs. If you haven't gotten a PC yet, or this is going to be your first PC, then for the average user, I would recommend 16 gigabytes of RAM in total. Because 8 gigabytes can be usable, but it's sort of like it's going to be like really close. There might be some times where if you like have too many Chrome tabs at once, you might start to see your computer slow down. And above 16 gigabytes is usually the point where most consumers won't use that much above 16 gigabytes. So now that we've answered that, then we also need to check about the speed of the RAM and how many sticks to buy. Is that the speed of the RAM is quite important when it's addressing how fast your computer is going to run. The faster your RAM is, the faster your computer is going to run. However, the faster your RAM is, it's more likely going to be a lot more expensive. So what is the best performance to price ratio when talking about the RAM speed. And currently, as it stands right now, the best price to performance ratio is 3200 megahertz, in which that it provides a very good performance for its price. So I would say that's a good starting point for the average consumer. Of course, if you're like on a tight budget, then you can feel free to like drop this a bit lower as well. Then lastly, we also have the issue of choosing how many sticks to buy. In that Amazon listing, we saw that most of them were options of 2 sticks, but there are some options that have 4 or maybe even 8 sticks. So how many sticks should you buy? And the general answer is that that's generally personal preference and what you're looking at. But the more sticks you have, the more reliable your RAM setup will be. For example, if you buy 2 sticks and one of them fails, you're going to only be left with half of your RAM. But if you have 4 sticks and one of them fail, you're going to still have 3/4 of your RAM. Excuse me. Is that of course this may not matter due to motherboard constraints, but we'll talk about that later. And if you buy less sticks, the benefit of that is that you get more upgrade potential should you want to replace your RAM or increase its capacity. If your motherboard has 4 slots and you buy 4 sticks of RAM, the next time you want to upgrade your RAM, you're going to have to take some RAM sticks out and leave some unused. But if you only have 2 sticks of RAM, then you can just simply buy another 2 sticks of RAM and not touch the existing memory. Now, next up is our hard disk, and the main option is what type of hard disk to use between the SSD, the HDD, and the newer NVMe SSD. The benefit of SSDs, as explained earlier, is that they're faster and more reliable, and however, they're much more expensive than the hard disk drive. And it should be noted that as of right now, the price between the traditional SATA SSDs and the NVMe SSDs are actually quite similar in price. So you can choose whichever one you want, although not all motherboards support the NVMe type. The HDD, however, is slower and more prone to failure, but the big selling point of it is that it is a lot cheaper to buy in bulk storage than the SSD, and also the HDD is also actually, sorry, that's about it. Is that now my recommendation is that no matter how much storage you have, you should always try to get an SSD for data that benefits to being accessed quickly, such as the OS and certain programs, in which that the OS should reside on the disk with the fastest speed, because the OS has to basically read through all of the parts on the drive. And if your drive is slow, it's going to take a lot longer for it to boot up. And whereas that in case for your like mass media like needs, like maybe you're storing a bunch of videos or homework that you don't need to access too often or aren't really that important, you can store it on the HDD, which is of a much larger size. And sure, it will be a lot slower than the SSD, but it's not as bad as having your entire OS boot slower because it's on the hard disk drive. Next, we're going to help to choose the video card, and there are 2 options in which that you can either stick with your integrated graphics card if you have one, or you can go with your discrete graphics card. So in this case, I would recommend buying a discrete graphics card if you are doing graphic intensive tasks such as photo editing, video editing, neural network, some types of servers, and gaming. Which these are examples of activities that require a lot of GPU power, in which that your integrated graphics card will suit you fine for like your casual use, like maybe doing homework. But if you're doing these tasks, it's best to go with the extra power that the discrete GPU has. Now, Now, once you've decided to chosen a discrete GPU, then there are also a lot of options in the discrete GPU market as well. So which one should you choose? The answer to it is, the advice I would give is that quite similar to the CPU, and it's that it's hard to tell the performance of a discrete GPU just simply based off the information sheet. This is again another example where you'll have to refer to real world testing in order to figure out which GPU is going to be right for you. Now we're going to choose the motherboard, and choosing the motherboard is a very important part because the motherboard will influence the entire computer, since every single part depends on it. And that, for example, in that example I showed you, you can see how the video card, the CPU, the RAM, and all the power are connected to the motherboard. So the main things I would look out for when choosing a motherboard is firstly the build quality. The build quality of your motherboard is quite important, as you want your motherboard to last long, as if that motherboard fails, it's one of the most expensive parts to replace. So along with that, you should also consider the functionality that your motherboard can provide. For example, if Wi-Fi, like are you okay with you either using antenna or just using Ethernet the entire time? Or do you really want to use Wi-Fi and just buy a motherboard with integrated Wi-Fi, so you don't have to waste time like setting up an antenna or having to connect to a wired connection? Now, when choosing a power supply, the main three things you need to consider is firstly the amount of power your PC will use. Now, this is where the online sites can help you a lot, in which that, for example, PC Part Picker will tell you how much energy your PC will use in watts. And however, if you're not using an online website, another good estimate is to check your video card power recommendation, in which that you can usually find on a manufacturer's website. And that recommendation is usually accurate because the video card uses the most amount of power in the entire computer. Then once you have that, then you should add about 100 watts to that number you've gotten from either PC Part Picker or your video card power recommendation, mainly because that oftentimes you want your computer to be able to run steady. Then after that, oftentimes power supplies won't like come in like every wattage. They'll like be spread out over like every 100 watts. So from that point on, you can just round up, and that'll be the power supply wattage that you'll need. For your power supply design, you'll want to try to aim for a semi-modular or modular power supply. This isn't strictly necessary, but a semi-modular or modular power supply will help you greatly in terms of organization and installation when you actually begin to assemble your PC. And lastly, we're going to talk about efficiency. The power supply actually uses more energy from the wall than it outputs, and that's because the power supplies are only a certain amount efficient, in which that you can see an example above the table, in which that in the table below, this is the 80+ certification, and it's basically used to designate how efficient a power supply is, in which that power supply certified 80+ silver, according to this chart, would be 88% efficient at 50% rated load. A more efficient power supply leads to a cheaper power bill, but the power supply itself will be more expensive the more efficient it is. So again, we're going to ask the question, which is the best price to performance ratio, the one that will give us the cheapest power bill while still maintaining the power supply at a reasonable price. And currently, I would recommend the 80+ gold to be in that range as of right now. And in which that you can see that the 80+ platinum and titanium oftentimes they're only separated by 1 or 2% in terms of efficiency. However, they can be a lot more expensive. Lastly, choosing a case is generally you have to pay attention to the ventilation and fans. And when choosing your fans, you'll generally want at least 4 fans to make sure that your PC has enough ventilation. And however, if your PC doesn't have that fans, you don't have to worry and like find another case. You can buy the PC fans separately and install it to your case later on. And of course, you also need to make sure everything fits as well. Then next, we're going to talk about the budget in which that we need to make sure we can make our money go the longest way and not waste things on unnecessary upgrades. For example, do we really need a larger like storage device over a faster CPU? Now, of course, this is where everyone needs will vary, since a lot of people might be using a certain part more often. But as a general guide, the upgrades that help the most is an SSD for the OS and programs to improve your loading times, so that way when you like start up, it doesn't take too long. Another upgrade that helps in general is the CPU, as the CPU can almost be as like a baseline for your PC components. And another good example is also the RAM speed, in which the RAM speed can also speed up a lot of your applications as well. But of course, all your needs will differ as well. So feel free to change this list based off your needs. Lastly, we're going to talk about compatibility. And compatibility is straightforward, but it's very important. Since all compatibility is to simply compare different pieces of information and see if they match. However, not having compatible parts can make it so that way you have to buy a new part that is compatible and having to send the old one back. Now, some sites can check compatibility for you, like the PC Part Picker. However, even PC Part Picker itself states that there are some things it can't check, and you have to check automatically yourself. For this one, I'm not going to talk about like all the things you need to check. Rather, I recommend just going over a basic checklist or a video that has all of these things in mind, and just follow them one by one, in which I've linked the video right here. So that's how you choose your parts, and unfortunately, I'm not going to stop for questions right here since we're starting to run out of time a little bit. But now we're going to talk about some general assembly instructions, in which that, as a quick disclaimer, this is a general guide, meaning that this guide will have a lot of generalizations. And this guide is still accurate because of how certain parts are standardized. For example, a CPU and a motherboard that are compatible will install the same way, even if they are different CPUs, as long as they're compatible. However, for some parts, that's not the case, and you'll have to refer to your manual or guide. And in some instances, your part may have like something special or like something that's non-standardized, in which that you'll also have to refer to the instruction guide or manual for each part as well. So aside from our computer parts, what will we need in order to build the PC? We'll need a flashlight, a screwdriver, which needs to be the number 2 size, and a number 0 if we're going to install an NVMe SSD, some Velcro strips, and a place to hold some small parts like screws in case to avoid losing them, and an anti-static wristband to discharge static electricity, which is optional. Now, before starting, you'll want to discharge static electricity by either using your anti-static wristband or by touching a grounded object that's conductive. Then, after you've done that, you'll want to find your workspace where you'll assemble your PC, and the material of your workspace really matters. It should not be metallic or conductive, and it should not be prone to attracting static electricity like carpet. Some good examples that fit this criteria are wood, plastic, or glass. So now we're ready to begin installing. So the first step is that we're going to take our motherboard and the CPU and we're going to install it. So the first thing is that you'll notice that the CPU and motherboard, which is circled in red now, you'll see they have a little marking that you need to make sure that that's the same size on the CPU and the motherboard. In which that here it's mostly triangles, but they can also be represented as dots. Then the second important thing when handling the CPU is that you should always hold the CPU from side by side in order to avoid damaging the bottom part of the pins or the conductors. In which that if you damage those parts of the piece of the pins on the CPU, they can be very difficult to fix, and you may end up just having to buy a new CPU if it's not covered under warranty. Now that you're aware of that, and once your CPU is facing in the right direction, you can begin to install by unlocking the slot by pulling up the tension bar in blue, in which that in this socket the tension bar is circled in blue. So you'll want to lift that up to unlock the socket. Oh, excuse me. And then we're also going to then grab the CPU from its side and gently drop it in, and then make sure that it fits snugly inside by putting one finger on top of the CPU and one thing on, and then like moving it around to make sure it fits snugly inside. Then after you have that done, then you can pull down the tension bar level. Now, if you have an Intel CPU, you'll notice that there'll be a cover in which that says to not remove this until the CPU is installed. And then once you've lowered that tension bar level with the CPU installed, you can remove that. For AMD motherboards or CPUs, you can just remove it in the first step. But regardless of that, you should make sure to keep that in order to make sure in case there's a problem to your motherboard, you can return it. As motherboard manufacturers will not accept a warranty if the CPU cover is not there. The second step is to install a CPU cooler, and this is a step where the instructions are not standardized, and you have to most often refer to your manufacturer. So this unfortunately isn't something I can help you with too much, just to follow the instructions. However, one thing I can help you with is the application of thermal paste. A lot of coolers already have thermal paste pre-applied, in which case you don't need to apply any more. But in case you do, then you'll want to apply thermal paste directly to the CPU by putting a pea-sized drop in the center of the CPU. And the photo you're seeing right now is a good example. Next up, we're going to use our motherboard again and install the RAM. So first thing I should mention before installing the RAM is that the size of the slot in which you install the RAM does matter. So you'll want to check your motherboard to see which slots you should insert your RAM in first. Once you have that figured out, then you can pull the tabs in blue in order to create more space for your RAM. And then once you have that done, in which that here, this motherboard has 2 tabs you have to pull back, but some motherboards only have 1, in which that case you can just pull back 1 or 2. Now, after you have that done, then make sure the notches on the motherboard is lining up with the notches on the RAM, in which that they're both circled red in this picture. Then after you have those lined up, then the way you insert it into the slot is that you just simply apply firm, even pressure to all of the RAM. And then once it's inserted in the slot, you should hear a click, and the blue tabs will automatically close. Oh, sorry guys, we're going a bit over time. I'll try to. So the fourth step is to install the storage, and this is only if you have the NVMe SSDs, in which that's better to install it first. For the NVMe drives, the way you want to install it is that you'll want to first locate the connector on the motherboard, and then you want to insert the pins into that connector at a 30-degree angle like this. Once you have that done, then you want to push the end all the way down to the motherboard to make sure it's flat. And then while it's seated like that, then you can screw in the SSD in order to secure it in place. Now we're done with the motherboard for now, and we're going to prepare the case. And while this can vary based off the type of case you want, you're almost always going to have to install the I/O shield that comes with your motherboard if it is not already pre-installed. So the I/O shield simply serves as like as a border around your I/O components to prevent any static electricity interference. The way you want to install it is that first pay attention to the direction that you're installing it in. You'll see here that there will be a side that has all the labels and another side that doesn't, in which here this is an example where it's showing all the labels, and you'll want that side facing outwards. Secondly, make sure that your I/O shield will line up with your motherboard when you put it in. You can do this by generally estimating by finding out where you're going to put in your motherboard and which direction it's going to be, and then from there you can just figure out how to put in which direction you should put in your I/O shield. Now generally the I/O shield will be like a slot that you just push in, and you're going to make sure that the I/O shield is really flush around all the edges, which is important. Otherwise, it's not going to be fully secured. Now that we've prepared the case, then we can install the motherboard into the case. The main thing here that we need to pay attention to these are standoffs in the case. And the standoffs here in this case are highlighted in red, in which the purpose of these is to make sure the motherboard doesn't come into contact with the case. So you'll first want to locate and align the standoffs based off your CPU/motherboard manufacturer's manual. And once you have it lined up, then you'll notice that there are holes in the standoffs and holes in your motherboard as well, where you can tighten in screws. Now it's very important that you don't over tighten them. That once you feel like a moderate amount of resistance, then that's where you should stop. And then make sure that's not so under tight to the point where you can just move it around with your finger, but not over tightened to the point where you're trying as hard as you can to tighten it. Then we're going to next install the power supply into the case, and generally the installation for the power supply is quite different, although this is one example. But one thing that you'll want to pay attention to is that you'll first want to see that your power supply will have a fan, and there will be an option for that fan to either face the bottom of the case, as it is shown in the picture, or the top of the case. And if your case has ventilation at the bottom, like maybe like holes or like ventilation shields, then you'll want your fan facing the bottom. If there is no ventilation at the bottom, then you'll want to face your fan towards the top. Then after that, make sure to attach all cables you need before putting the power supply into the case. This will help a lot easier in the later steps. Next, we're going to connect the front case connectors. Our case also has something such as like I/O ports and the power button that need to be connected to the motherboard as well. So here you can see on the left about what these wires look like, and you'll notice that there is a polarity marking, like a plus or a minus on the switches. And the direction you put those on the motherboard does matter, so pay attention to that, in which that the instructions will say which way you should put it on. And then And then of course on the right you can see an example of where on this computer where you would put on the motherboard, but you should also contact your motherboard manufacturer. Next thing that we need to mention is that we also need to power our case fans by attaching it to the motherboard. And it's a very similar process comparing it to the connecting the front case connectors. It's just that we're going to need to install it on the different on a different header, which is usually labeled on the motherboard itself or the motherboard manual. Next, we're going to install our storage if you don't have an NVMe drive, which is the 2.5 and 3.5 inches drive. On cases, there will be a place where you can mount and screw in your drives in the designated area, but that place will vary depending on your case. So check your case manual. Then after you've mounted the drive in the designated area, then you also need to attach the power and data cables, in which that you can see on the left, the red circle is the power and the right is the data cables. Your power cable will be connected to your power supply, in which that you can just connect, that you can just lead, since most cases will have like places where you can like go through the case from the back to the front, and you can just put the wire through there. And as for your data cable, you'll just install it from your drive all the way to your motherboard. Now, what's important to mention is that the direction in which you put these cables does matter, and that's going to be true for almost all the cables, similar to the front case panel connectors, in which that if you put something in the wrong way, you can actually break the part or your cable. Lastly, we'll want to attach two of our power supply connectors, such as the motherboard and the CPU, in which that the motherboard is a large connector, while the CPU is usually an 8-pin connector twice, in which you'll put the motherboard connector in the designated area, while the CPU connector is split into two 4-pin connectors at one end, and the other end is just a full 8-pin connector. You'll want to put in that 8-pin connector into the power supply and plug in two of the split end into your motherboard. This is done because some motherboards will only use 4 pins, and while others will use 8. So if you have a motherboard that uses 4 pins, then you don't have to search for a cable that only has 4 pins. You can just simply get a cable that has a split end, so that way you can just leave the other one. Now this step is optional, and it's only if you have a video card installed. Now what we're going to install it in is in a slot called the PCIe slot, which is located just below your CPU. So here is an example. Well, you can notice how it's quite similar to the RAM, where you have like a similar cable to the RAM circled in red and the notch in blue. But what's different about here is that you'll also see some cages directly to the left of it that you'll need to remove, in which that you can see that there is sort of you could say a separation in between each of the meshed metal, and then each of those separations each show the size of one slot, and most dedicated video cards will have 2 slots. So in this case, you want to remove the slot up below it and the slot directly horizontal to that slot. So once you remove both of those slots, then your graphics card will have enough space to fit in. Then after that, then you'll just install it in a very similar way to your RAM, in which that you'll just make sure that your video card is lined up with that notch, and you just push with firm pressure until it clicks in. And just like the RAM, it's going to automatically tighten the cap around it that you loosened first. Once you've done that, then you can connect your power to the RAM, to your video card, and then fasten the 2 slots that you took out earlier. The last part is cable management. And this is something I strongly recommend you to do. And this is where you have to try to route each cable as neatly as possible in the front, on the back, in which that your front is more like the most important part, since you don't want any like stray cables on the front. And because not only does it look messy, if it touches your ports, it can also interfere with them. So you're mainly going to try to route all of them through the back mostly, and you'll want to group them together to make sure there's no stray cables left. You also want to pay attention to airflow, since you don't want your cables to block any fans. And you can also take advantage of any like unused space. Like for example, in this example, there's a lot of unused space at the bottom. So what this guy is doing is that he's putting all of his cables at the bottom. So at this point, our computer will boot, assuming nothing has gone wrong. However, we still need to install our software. So now we're going to have to configure the BIOS, and the BIOS is just simply a page that is responsible for all the settings for the motherboard and different types of hardware. Now what you need to do is that one thing that you must do in the BIOS is to configure boot priority, in which that you can see in the circle, in which that you'll see a list of all your bootable drives connected to your computer. However, since your hard drive is like completely fresh out of the box, it's not going to have any OS installed. So in order to install an OS, we're going to need to connect the flash drive to our computer and then change the boot priority so that way it'll boot from our OS installation media, and then that will read us, and then we can install an OS from there. Other things that you'll need to do is maybe you'll need to change the RAM speed, since oftentimes the RAM speeds manufactured, what they claim is that may actually not be that speed out of the box, in which that you have to adjust it to that speed manually. In which that I recommend doing this after you have used your computer for a couple weeks, however, to make sure the RAM is working fine. And lastly, now that you've installed your OS, install your OS is pretty straightforward, in which that if you're installing Windows or Linux, it should just walk you through the step-by-step process. So for your installer. Another thing that a lot of people have been doing recently is to install 2 OSs on the same drive. And this is what's called dual booting, in which that you're setting up 2 areas called partitions. Now, if you want to do this, it's important that you install Windows first, then Linux. As Linux will let you will preserve your Windows installation if you've already installed Windows, but Windows will not preserve your Linux installation if you've already installed Linux. Lastly, you'll want to install your drivers to make sure, since drivers are the soft pieces of software that help your hardware parts work. For example, you'll mainly need to install video card drivers and some motherboard drivers, since if you're installing Windows, most drivers will automatically be installed for you. Now, the way you can install these drivers is by going to the manufacturer's website and then choosing which driver to install. And then from there, you can just run an executable file and it will install the driver on your computer. So if you made it to this point without any issues, then congratulations, you have a working PC that you are free to customize now. Unfortunately, it's not always like that, and there are some issues where your PC doesn't work. Now, firstly, before returning your parts, you should make sure that your connections are all snug and that way you haven't missed a simple step, which is usually the case for your computer like not powering on. Now, now the second tip I'll give you when troubleshooting is that if you've gone through that, and you can then the second thing I recommend you do is to grab another device and search up the problem, which is very useful as a lot of people will provide a lot of helpful or detailed instructions about how to solve specific problems. Thirdly, when trying to diagnose the problem yourself, you'll want to make sure to do only one thing at a time, in which this is to keep track of which change causes which thing. And lastly, a thing that can also be very helpful is a motherboard feature called a Q code. The Q code allows you, basically shows the state of the motherboard and it can also provide error messages in case something goes wrong. For example, a list of a Q codes for a certain motherboard is listed below. And for this motherboard, if we were to see the Q code 55, then we would know that our memory is not installed. And then if we were to check and find out that if it was actually installed, then we could easily nail it down to an issue with with the memory or the motherboard. Lastly, this is if I assume most of you are going to have school computers, but this is mainly just review. Generally you should keep care of your custom PC just like any other PC, in which you need to keep the area around the PC clean, put the PC into sleep when not using it to save energy, and as always, some basic software things such as be careful what you download, um, and also make sure to regularly clean it since the PC can attract a lot of dust. And with that being said, here are all the resources I used, and you can also check them out yourself if you need to, and if you're interested in further things. And lastly, I would like to apologize for how long this presentation has taken, since I know I went over my time a lot. But I would like to thank you all for listening, and now we are going to go into the Q&A session. In which if anyone has, I'll stop screen sharing now.
That was a nice presentation.
All right. All right. So Eric says I have a rather complex question. That's okay. You are free to ask that, and I'll try my best to answer it. So Eric says, if I'm on a tight budget, would you recommend getting cheaper RAM and downclocking it to the infinity fabric that the CPU gets and run a 1-to-1 ratio instead of buying a more expensive RAM that would match the CPU at a 1-to-2 infinity fabric ratio instead? And that's a good question. And unfortunately, I can't really do much to do it, since whenever I installed my computer, I did not really experience the Infinity Fabric. Wait, actually, Ewa, could you clarify what the Infinity Fabric is, since I'm not quite familiar with it? Hello? Yeah, unfortunately, this is something I'm not really familiar with, so I don't think I can like provide help, especially since I don't want to like say something that's incorrect. So sorry about that, unfortunately. But thank you for your question, though. All right. Does anyone else have any other questions? All right. So it seems like no one has any other questions. So I'm going to stop my presentation. And once again, thank you all. Oh wait, actually Eric has a question. I'm not really Eric says that I'm not really sure myself, but to my understanding, the Infinity Fabric is how much of the RAM speed will run effectively. Oh, Eric, are you talking about without going into how CPUs work internal? So are you talking about the speed of what the default RAMs of what the default RAM speed is, Eric? Is that what you're referring to? Or hello? Alright, so we'll let Eric answer this question. But if you don't have any more questions, you're free to leave, and I'm so sorry for keeping you so long here. So if you don't have any questions, you are free to leave, and thank you for attending.
Cool, thanks.
Yeah, no problem.
Bye.
Oh, okay, let's see. Oh. So that's a good question actually, and unfortunately, I would say that I'm not really too familiar with this since now I think I understand a little bit about what Infinity Fabric is, but unfortunately, I'm not quite sure what the answer to your question is. Unfortunately, oh, which I'm sorry to say that, but I appreciate your question and thank you for asking though. All right, so all right, so Kevin. Yeah, I understand. Yeah, I understand. Is that PC parts are like a lot of times they're quite complicated. So you'll want to oftentimes you'll like Google, I would say, is your best friend when you come across these situations. So all right. So all right. So Kevin, do you have a question or all right. Yeah, thank you too. Thanks for attending, Eric.